I welcome you all to the Spark Research YouTube channel. This is Dr. Virchand, Assistant Professor in the Department of ECE, and here is the 12th session of this current 2026 series. And here we are taking the questions which has already been asked in GATE 2026, which is organized by IIT Guwahati for this particular stream, Electronics and Communication Engineering. So these sessions will be very helpful for you if you are preparing for GATE 2027. And why is this will be very helpful? Because we are not only talking about the question and answer for these questions, but also we are depth, the analysis it in a very depth. So it will be very helpful for you if you are preparing for GATE, right? So currently we are taking the question from this particular subjects, that is signal and system, and in this session we are going to take the question which is the related with the very basics of the signal properties. So here is the syllabus, and questions may come in the range of the the 10 marks. So these courses are very helpful for you to score the good gate marks, right? And we are going to take the question from the basics of the signals. So let's take the question now. So question number 46. Consider a real baseband signal xt is equal to minus 2t. So your signal is given xt is equal to minus 2t. Something like this is your xt is equal to minus 2t, right? And for t greater than 0 in this, of course, t is already greater than 0 here, and suppose this is 0, and your time axis, that is your axis, right? Now, if 99% of energy of xt lies within b hertz, means suppose 99% of energy these lies still here only, right? This b hertz only, right? If you are converting time domain into the frequency domain, means in the then definitely you will get the exact figure. But here suppose I am roughly drawing. So then which of the following option is true, right? So in this reason only 99% is true, 99% energy occupied. In this reason very few energy, right? So this cutoff, that what is this b, so value of the b is 1 kilohertz, or in between these, or in between these, or in between, what will be the correct answer? So as per your answer key, your answer b is correct, right? So we have to find out the b, that is the range of the your bandwidth at which the 99% of energy for this particular signal will lies, right? So let's solve the question. So first of all, x of f you can find that is in the frequency domain, because question is asking about the frequency. B is nothing, that is bandwidth, that is frequency only. So that is why let's find out in the b the frequency. So how will you convert in the b, that is in the frequency domain? So using the Fourier transform. So x of f is nothing, your x of t, and then how will you transform this Fourier transform into the power minus j omega t dt, right? So then take the Fourier transform, you will get the x of f of all is, then after getting the Fourier transform, you can take the x of f square, so that you can get the energy. So this is x of f square. Now let's try to find out the energy. So energy is nothing, minus infinity to infinity x of f square df. So integrate it from minus infinity to plus infinity, you will get the total energy. So once if you'll put all these values, then if you'll further, if you'll solve now, you will get the value energy is equal to how much? 1 by 4. Just a reminder is that the integration is from minus infinity to infinity, means the total energy is how much 1 by 4. But in question it is asking that only in between minus b2 plus b, before b only, right? So now integrate energy for minus b to b. So here the same integration means same integration we will apply with the minus b to b. So again, if you'll solve it for minus b to b now, then your energy will be how much? This will be 1 by twice pi, and 10 inverse pi by 10 inverse pi b. This will be the energy, right? but in question it has also given that 99% of the E means total energy in this region will falls, right? So let's make it equate. So EB will be equal to 0.9999% of total E. So what is the value of the total E? That is 1 by 4. So 0.99 into 1 by 4, and this will be equal to this. This will be equal to E of B that we have already calculated here, right? So let's equate, and if you equate it, then you will get the value of B after solving it, right? So B will be how much, like 20.27, which will falls in this range, right? So that is why, as per your answer key, your option B is correct. That is 63 by pi, means B is in between 63 and 64 by pi, right? In another manner, you can reanalyze the same questions, like your x of t is already given here. So you can find the total energy used, and that is a formula, that is x of t whole square dt, right? So you can get the value, that is 1 by 4 also. And then using the Parseval's theorem, that is x, and you can find out the x of f in between minus b to b, right? So this is integration for, the in between 0 to infinity. So x of f of square, you got it, and now integrate it in between the minus b to b in order to get the energy till 0 point, the 99% energy. So once you will get it, then after finding the b to b, you can equate the values whatever you got, that is 1 by 4. So 99% of 1 by 4, and then you can solve, then you can finally get the value of b, and that b is lies in between 63 and 64 by 5, right? So this is the steps to primary algorithm. So let's take some more details. Say the frequency, Fourier transform is a mathematical tool that converts a time domain signal into the frequency domain, right? And how will you convert? So this is the f of t that you want to convert from time to frequency, and this is the exponential that you have to multiply in order to convert, right? Exponential of minus j omega t and dt, and integrate it over minus infinity to infinity, and finally f of w you will get, that will convert it into the frequency domain, right? And what is this? F of omega is frequency domain representation of f of t, and omega is the angular frequency, and exponential function represents the complex exponential functions, right? That is sinusoidal. As for example, suppose we want to convert this time domain, that is cos omega t, into the frequency. How can we do it? So f of omega, first of all, formula we can write. This is your function that you want to convert, and this is the multiplication factor. That is, we have to multiply by e to the power minus j omega t, and integrate it over minus infinity to infinity. Now, how will integrate this? So this is the one challenge. So in order to integrate it, first we will break this cosine function into this exponential. So use Euler's formula. Cos theta is equal to half of e to the power theta plus e to the power minus theta. So we'll break into this, and then we will multiply with this exponential function, and then we'll convert back in the after the integration. So finally your functions will be pi of del of omega minus twice pi f naught and plus del of omega plus twice by f naught. So this is the process, right? So just put the function that you want to convert, multiply by this exponential function, and integrate it over minus infinity to infinity. So this is the steps, right? Nothing else. And energy and power signal. Now let's find. So first of all, how to find the energy of any signal? So integrate over the minus infinity to infinity, and take the square, right? Xt magnitude square into the dt, right? So integration of xt magnitude square and dt from integration over minus infinity to infinity. This is the energy. And power is that, the you have to divide by the average, that is the 1 by twice of t, the time period, right? T is your time period. And if your energy, once you will calculate using this formula, if energy is finite, like 1 2 3 4 or any numbers, then this will called as a energy signal. And in this case, if you will calculate the power for energy signals, then it will be 0, right? And similarly for power signals, you can calculate the power, that is 1 by twice t, and integration from your particular time period only, minus t2 to xt square dt. Here we are taking average, right? So power is the average and energy is total, right? So 1 by twice t, and calculate it and check whether power is finite. If power is finite, that is called the power signal, and in that case energy will be infinite. So very simple, if power is finite, that is called power signal, and if energy is finite, that is called energy signal. And how to calculate energy and power for any xt? So energy you can calculate xt square and dt, and power, calculate that energy over the particular only time period and divide by that time period 1 by twice of t, that you will get the power, right, for that particular signal. Here I think we'll see the example here. So energy, for energy signal, energy is in between 0 to infinity and power is 0. And for power signal, your energy is infinity and power is finite, right? Example is your decaying exponential function is an example of your uh, energy signal. So you can calculate this. This will give the finite value of energy, and power is, power is 0 because the time period is not there, right? And similarly your signal, the sinusoidal or any cosinusoidal, all are the example of the power signal. Why is it so? Because time period is suppose 0 to twice pi for sinusoidal or cosine function, 0 to twice pi. If you will, the absorb the power for this only one time period, then it will be finite, right, for only one time period, not, and energy is for entire time period, so that is infinite, right? So in this case, power is finite and energy is infinite. Okay, so thank you to join the session. So play today, stay healthy tomorrow, and learn for a lifetime. Thank you.